In this video, we're going to talk about inverse variation. Inverse variation in most real-world applications is the idea that two things change in opposite directions. Alright, so the method one for identifying inverse variation is we can look at the formula. The formula is y equals k over x. So we need to be able to rearrange all of our formulas into, or all of our given formulas into this format right here. So examples determine if the following are examples of direct variation. So the thing to look for is, do I have a number up top, k is a number, and do I have a variable in the bottom and a variable on the left. So example 1, c equals t divided by -4. This is going to be no. I have a t in the numerator instead of a number. Alright, next example. It's not in this format, but I need to check to make sure that I can't rearrange it. So I'm going to try to solve this for y. Subtract 3 from both sides, and I have xy equals -3. To solve for y, I would then divide both sides by x, and lo and behold, I end up with y equals -3 over x, meaning that this is indeed an inverse variation formula. Didn't look like it at first, but it can be transformed. All right, example 3, I have m equals -5p. There's no way I'm going to be able to transform it into this. So my answer is no. And if you remember from the last video, this is actually an example of direct variation. We have m, a variable on the left, kind of like y, a slope, and a variable on the right. So that one's a direct variation. All right, last example, I have xy equals 5. I want to see if I can rearrange it into this formula. So I'm going to divide both sides by x, and I end up with y equals 5 over x, which is my inverse variation formula. So this one is yes. All right, method 2 for identifying is we can look at the graphs. In order to determine if a graph is inverse variation, it must not touch the x or y axis, and it must be a hyperbola. So a hyperbola is kind of like a parabola that's been shifted a little bit, kind of split up, and it's kind of easier to show you a picture. So for example, this is a hyperbola. So it's taking like a U shape, but it's kind of splitting it up. A little bit difficult to describe. This one does not touch either axis, so this one is going to be yes, inverse variation. Example 2 is going to be no. You'll notice that there's a place where it crosses the x-axis, so this one is no. Number 3 is yes. It's approaching both of the axes, but it's not actually touching them. And number 4 is going to be no, as we touch the x-axis right there. Method 3 for identifying inverse variation, we can look at a table. And when we're looking at a table, we want to consider the formula k equals yx. So we're going to multiply the x and y values together to see if we come up with the same number. So I make a third column, xy. -2 times 1 is -2. -1 times 2 is -2. 1 times -2 is -2. And 2 times -1 is -2. So the answer is yes, I came up with the same number every time. So that's going to be an inverse variation. Third column for this one, -4 times 1 is -4. -2 times 2 is -4. 2 times -2 is -4. And 4 times -1 is -4. All those numbers are the same. So yes, I have an inverse variation. Okay. This last example ends up being the same as this one, but let's just go ahead and change these to a -1 and a -2 so you can see what happens when it's not an inverse variation. So I'm going to make my third column xy. -4 times -1 is 4. -2 times -2 is 4. 2 times -2 is -4. So I end up with a mismatch. So no, that one's not going to be a inverse variation. Alright, so we're going to put this all together and we're going to start finding some given values just like we did last time. So the steps, we're going to find k using the equation k equals yx. And then we're going to write the direct variation equation, y equals k over x. And then we're going to solve the problem given. Alright, example number 1. Each pair of points is on the graph of an inverse variation. Find the missing value. So I have 2 points here. First thing I need to do is find k. And I can find k using the ordered pair that's already given to me. So k is going to be 3 times 5, or 15. Step 2, I'm going to write my equation. This is where I put y and x back in, and then plug in the number that I got in step 1 for k. So y equals 15 over x. I'm solving for n. N is a y value, and I'm given an x value. So y equals 15 over, my x value is 1. So y equals 15 would be my final answer. Okay, number 2, I'm going to start with the ordered pair that's given to me, and I'm going to find k. So k is equal to y times x, so 1/4, times negative 1/3. So my k value is going to be negative 1/12. I'm then going to put this into my direct variation equation. So y equals negative 1/12 divided by x. In this problem, I am looking for an x value when y is equal to 1/2. So I'm plugging in 1/2 for y, and that's equal to negative 1/12 over x. I'm going to have to solve that for x. This can be a little bit tricky. So the first thing I want to do is I want to get rid of the x in the denominator. In order to do that, it's division by x, so I'm going to multiply both sides by x. That gives me 1/2 x is equal to negative 1/12. I'm going to come up here, copy that again, 1/2 x is equal to negative 1/12. And then I'm going to divide both sides by half to solve for x. So that gives me x is equal to negative 1/12 divided by 1/2. And then I'm going to use my fraction rules. This is going to give me negative 1/12 times 2 over 1, which is negative 2 over 12, and a final answer of negative 1 over 6. All right, last example, number 3, the first law of air travel. And this is kind of a jokey question, but it says the distance to your connecting gate is inversely proportional to the amount of time you have. So this is basically saying that the further you are, the less time you have. So if you're really far away from your gate, you have a very small amount of time. But if your gate in the airport is right next to the one where you landed during your stopover, then you're going to have hours to sit there and wait. So again, kind of jokey, but it works for this particular example. So suppose when you have 1 hour to get to your gate, the gate is 600 yards away. According to the first law of air travel, how far would your gate be if you had 10 minutes to get there? So we're going to start by identifying our ordered pair. So the distance to your connecting gate is going to be like your y. List that first. And the amount of time you have is t. So the ordered pair that we're given is 1 hour, so 60 minutes, and your gate is 600 yards away. So now I can find k. So k is going to be 60 times 600, which gives me, try that one more time, 60 times 600 is 36,000. So then step 2, I'm going to plug back in, so y equals 36,000 over x. And then step 3, I solve the problem. So according to the first law of air travel, how far would your gate be? That's your distance, that's your y if you had 10 minutes to get there. So y equals 36,000 divided by 10, which gives me y is equal to 3,600 yards.